2.4, linear functions, basically lines. We know a linear function can be written in this form. You may remember this as mx plus b form, but that number right there is the slope. And so you've seen it before, mx plus b. In this case, they write it ax plus b. It doesn't matter, it's the same thing. It's a line. It has a slope. Example 1, graph this thing, tell if it's a linear function, and then give the domain and the range. So the first one just looks like a slope-intercept form that we've done a million times. So 3 halves x plus 6. We go up 1, 2, 3, 4, 5, 6, and do a dot, and then up 3 and over 2. I know you've done that a million times, all right? 2 points is probably enough. I know if you're like me, you're programmed to want more. We can reverse the pattern, and we can do more points. Down 3 and left 2, down 3 and left 2. You can do as many as you need there, but really 2 is probably going to be good enough. There's your first equation. That's f of x equals 3 halves x plus 6. I'm just going to label it on there because I'm going to put the other lines on the same graph. So graph it. Tell if it's a linear function. Well, we talked about vertical line test yesterday. Imagine the vertical line test. Shoot some vertical lines through. And yeah, it's going to be a function. For domain and range, that's where I talked about squashing it onto the x or squashing it onto the y. If you took that line and you squashed it onto the x-axis, it's just going to flatten out. It's going to cover everything. And so the domain is going to be all real numbers. Likewise with the range, if the walls close in and it squashes onto the y, it's going to cover up all the y numbers. Okay? We're talking about all of the y numbers, so the range is also negative infinity to positive infinity. F of x is like y. So some people have more luck graphing y equals 2, but that's the same thing. F of x equals 2. There's y equals 2 right there. Your f of x equals 2. It's going to be a horizontal line. Again, horizontal line test tells me that's a function. The domain is going to cover all of the real numbers. Not the range, though. The range, if you squash that onto the y-axis, if you only look at the y numbers, it's only one number. It's only a 2, and that makes sense if you think about the equation as being y equals 2. So then the third one there, x equals 5. That's the only one that's different. X equals 5. 1, 2, 3, 4, 5. That's going to be a vertical line. It's going to be a vertical line right there. X equals 5. And so the vertical line test is going to hit everywhere. This is not a function. The domain, it only touches one x number, x equals 5. That makes sense. Think about the equation. The range, though, is going to cover everything. That's all real numbers. Standard form of a linear equation. Standard form is ax plus by equals c. And I know you've seen this before, but most students aren't as comfortable with standard form as slope-intercept form. Yes, question? I'm sorry, what? What was the domain and range for the last one we just did? Okay, we can go back. The domain of the last one was 5, and the range was negative infinity to positive infinity. So when we talk about standard form, ax plus by equals c, you've got all these extra little things you have to consider. A is greater than or equals 0. A, B, and C are integers, not fractions or decimals. The greatest common factor of A, B, and C is 1. Basically, that means the equation is reduced. And then if A equals 0, then b is greater than 0. If you take the first two little bullet points together, basically what that says is the first number you see is going to be positive. That's all that says. The first number is going to be positive, whether it's the first number is A or B, it's got to be positive. Example 2, we're going to graph an equation in standard form. Now I messed up here, and this should not be in there. Copy pasted wrong or something. It doesn't need to be there. We're going to graph that equation 2x minus 3y equals 12. That's in standard form. Now, most of your gut instinct tells you to put it in slope-intercept form. So if you're thinking I'm going to subtract 2x and then divide by negative 3, you can do that. That's fine. That'll work. That's not what I'm going to show you here because I'm just going to talk about standard form. If you know what you're doing with standard form, you can maybe do it quicker. So what I'm going to do is make a table. Make an XY table. And we all know the easiest number to plug in is going to be 0. So I'm going to plug in 0 for my x. And so I'm going to do this in my head because 0 is so easy. What happens is 0 plugs in for x and makes all of this stuff 0 right here, resulting in a really easy equation that I can solve in my head. Negative 3y equals 12. Divide by negative 3. Y has to be negative 4, right? Y has to be negative 4. So I know a point, 0, negative 4. I'm going to graph it. 0, negative 4 is right there. Now I need another point for my table. And here's where most people overthink it, okay? Most people will plug in like 1 or 2 or something like that, but that's not as easy as what I'm about to do. What I'm going to do is plug in 0 for y. I love plugging in 0 because it's so easy. You plug in 0 for y, and all this stuff goes away. I get another easy equation. 2x equals 12. X has to equal 6, right? So I've got another point right there. And that's all I need. If I've got 2 points, I've got it. Okay, so I know I talked over the problem there, but if you're doing this on your own, you can plug in 0 really quickly and get 2 points really quickly. Now, what if you want to put it in slope-intercept form? Well, that's fine. You can do that too. Okay, you could do the slope-intercept form. Graph the line right there. Give the domain and the range. Okay, well, this is a diagonal line. If you squash that line, it's going to make a flat line, or it's going to make a vertical line. Okay, it's going to cover everything. So both the domain and the range are all real numbers. So then part B. Again, if you want, you could isolate y. You could change it to mx plus b form, and that's fine. If that's what you want to do, go for it. But I'm going to make a table. Okay. If I plug in 0, and that x drops out, I've got 4y equals 0. So y is going to equal 0 there. So I've got this point 0, 0. Now here's where people get fooled. You can't plug in 0 for y because we already know what happens when y equals 0. When y equals 0, x equals 0. We've already got y as 0. So if I want to do this by making a table, I'm going to have to plug something else in. Okay? And you can plug in 1 if you want, and you can plug in 2, but the way this works, you're going to get a fraction unless you plug in a multiple of the other side. So I'm actually going to plug in x equals 4. So if I plug in x equals 4 right here, 3 times 4 would give me 12 plus 4y equals 0. I might not do all of that in my head. It's not nearly as easy as when I plugged in 0. Subtract the 12 over 4y equals negative 12. I can divide by 4, and I get y equals negative 3. So I've got the point 4 comma negative 3. Right there. Ooh, missed. There's my line. Again, a diagonal is just going to flatten out and cover everything. So the domain and the range are both going to be all real numbers again.